So section 6.1, solving inequalities with add and subtract. So starting with writing inequalities. If you look at this first expression, it is read as x is less than 1. So you always read your inequality from left to right. So whatever you see on the left side of the inequality is how you read it. Since it's the small side, it's less than. So x is less than 1. Okay, another example. This expression reads as y is greater than or equal to 4. So then what does that mean as far as what is x? So when we look at x less than 1, that means all possible values that are smaller than 1, including all negative numbers, 0, and any fractions between 0 and 1. So it includes all the fractions and decimals that are less than 1. It does not include 1 itself. And y, what is y? Y is all the numbers that are greater than and including 4. So any number that is a 4 or bigger would satisfy that expression. Okay, graphing inequalities. So there are a few notes here on how to graph inequalities. We'll start with write the inequality so that the variable is first. If you write it so that your variable is first, then the inequality symbol, then the value, graphing the inequality is a direct relationship to the direction the inequality is going. So it helps with the graphing. Okay, so if your inequality is strictly less than or strictly greater than, then you're going to use an open circle. And that indicates that the number that the open circle is on is not one of the solutions, but everything above or below that value are solutions. If the inequality is a less than or equal to or greater than or equal to, then you would use a closed circle. So a circle colored in. So the closed circle indicates that that value is also one of the possible solutions. So if the variable is first, the arrow goes the same direction as the inequality. So that's why I emphasized in the first step to make sure that your variable is written first in your inequality expression. Then when you're graphing, the arrow for the graph will go the same direction as the arrow for the inequality. Okay, so we have some examples next of graphing inequalities. So here's the first one. Let me move it up a little bit. All right, so we have x less than 1. So since it's strictly less than, think about what kind of circle we're going to use. Okay, this is going to be an open circle. And since our variable is first, our arrow is going to point in the direction of all the numbers that are smaller than 1. And it would go in that same direction as the inequality. So our graph would look like that. I usually put the line above our number line. You can put it on the number line like that. Sometimes it's a little harder to see, so myself and most students tend to like to put it just right above so that it's a little easier to see your graph itself, which direction the inequality is going. Okay, next, x greater than or equal to 4. So think about what kind of circle you're going to use. It's going to go on the number 4. So if we take a look at, and then which direction the arrow goes, your graph would look like that. So you have your closed circle on the 4 and the arrow going towards the right where the numbers are bigger than 4. And the closed circle indicates that 4 is also one of the solutions and is included. Okay, another example. X greater than negative 3. So think about what kind of circle am I going to use? Which number is it going to go on? And which direction is my arrow going to go? So you would get a graph that looks like this. So you have an open circle on negative 3, and we want numbers that are bigger than negative 3, which are the numbers to the right. Note the arrow goes the same direction as the inequality symbol. Solving an inequality expression is done the same way as solving an equation. So in this case, m minus 3.8 is less than or equal to negative 1. So I want to solve for the variable m. I do that by adding 3.8 to both sides of the inequality. So then you get m by itself on the left. M is less than or equal to 2.8. Now we want to graph that solution. So you find 2.8 on your number line. We're going to use a closed circle because of the less than or equal to. The equal to part indicates that you would use a closed circle. And that line underneath is the equal to part. And the direction of our arrow is going to go in the direction where the numbers are smaller than 2.8. So that would be to the left. So our graph would look like this. Usually when a number is between two numbers on the number line, we write that value on top of the circle that we drew to indicate what the exact number is supposed to be. So if I didn't have the 2.8 there and you didn't see the problem itself, you wouldn't know exactly where between 2 and 3 that number was. So writing the number on top is helpful in identifying what the actual solution was. Let's look at our next example. So we have number 2. 1 is less than or equal to s minus 8. So just like solving an equation, we want to isolate the s variable and get the s by itself. So think about how you would solve an equation of this same format. Okay, so hopefully you're looking at adding 8 to both sides. So we add 8 to both sides, and 8 plus 1 gives us 9, less than or equal to s. Now if you recall, I mentioned earlier when we're graphing, also when you're solving, to make sure that your variable goes first. So when you're solving an inequality, make sure you rewrite your answer so that the variable is first. And then when you do your graphing, it will help you with the graphing. So just take the inequality that you have, you flip it around. Okay, so the s goes first. Note that the larger side of the inequality is pointing at the s, so the larger side of the inequality has to continue pointing at the s. And the smaller end of the inequality is pointing towards the 9. So when I flip it, the smaller end of the inequality should be pointing towards the 9. So s greater than or equal to 9 is our final solution. So for graphing, the equal to is there. So we're going to have a closed circle above the 9. And it's going to go to the right where the numbers are bigger than 9. So that's how our graph would look. Okay, we have one more slide, a couple more examples. All right, so our first, b plus 7 or is greater than 3. So b plus 7 is greater than 3. So we're solving for b. So just like solving equations, we're going to subtract 7 from both sides of our inequality, and our solution is b greater than negative 4. And then you continue with your graph. So open circle, because there's no line under the inequality, on negative 4, going to the right. Open circle, on negative 4, going to the right. Okay, I hope this was helpful. If you have additional questions, please make sure you write them down so that you can ask them in class. And then we will talk about solving with multiplying and dividing inequalities.